Okay. So, was it yesterday? We started talking about naming yesterday, I believe. And we talked about how the fact that some of the charges, some of the atoms on our periodic table have two charges, right? And many of them exist in the transition metals, okay? So examples of these that have more than one charge, or we say that they're multivalent, where valence means the charge, means that has more than one. Things like copper, 2 and 1, and nickel, 2 and 3, cobalt, 2 and 3, iron, 2 and 3. Manganese has all kinds of them. Manganese actually behaves more like a metal, or like a non-metal. It has 7, 6, 4, 2, 3, right? So many of them can have all kinds of different charges. Now, what we need to do when we're naming things is be able to identify which of the charge to use. Because as you know, to get the formula, we get the charges and we cross them over. So the question is, how do we know which charge to use? All right? And then in the reverse, when we come up with the name, we've got to designate which type of iron or which type of copper that we're talking about. And that's what we want to talk about now, what we do when we have multivalent ions or metal ions. So let's see, I got you a ribbon and a winner's cap, but I'm sorry, I don't have a tiara. So Your Highness, I apologize. I'm calling her a princess. That's what I'm doing, without actually saying you're a princess. Amy McCormick, princess. Anyway, in order to tell which charge a multivalent metal is using in a compound, we include a Roman numeral beside the name. So we simply add brackets with a Roman numeral in it to state what type of ion that is, and that's how it goes in the name. So if I'm talking about something like sodium, it's only got one charge, so I just say sodium. But if I'm talking about something like copper, the question is, which type of copper is it? And so I have to say whether it's copper 1 or copper 2. So it becomes part of the name. We have to designate what the charge is. Again, you don't necessarily need to write the grid. This is the ion. We're going to write the name. Again, you don't necessarily need to draw the grid, but this is a reminder of Roman numerals. Very rarely do we use 8. There are very few ions that have a charge of 8. 7 can exist. Manganese has 7. To be honest, I don't even know what has 8. I guess xenon can have 8. Because it's that noble gas that you can kind of trick it into bonding with 8 of its electrons. Very rare, very rare. That is probably the only 8 on the periodic table. I've never actually looked to see if there's any other 8s. 7's in here, but to have a charge of 8 is very rare. And there's only 1. 1, 2, 3, very common. 4. Lead and tin can be 4. They're in that group 4, so they can be 4. So we're talking about a lot of the transition metals, and we're talking about many of these metals down here below the stair-step line. So I don't know where we are in our writing. Am I ready to do the examples? Are we there? So copper with a +1 charge is simply called copper 1. I don't put the little hats on them. I'm too lazy. Copper 1. That's not a number 1. That's still the I, right? But I write it as copper 1 like that. And you could put ion, because we are just talking about the ion. But when I put it with something like a chloride, I'd call it copper 1 chloride. Yep. You have to put what? Oh, no, you can't. You have to, because you must differentiate between a copper 2 ion. No. You're trying to generalize the rules of when you cross it over, you don't write 1s, or if you have a balanced chemical equation, you don't put a 1. But we must have this because I need to designate that it is the number 1 versus the number 2. So I need it to separate out the difference between 1 and 2. What am I going to write for this one? Yep. Iron, and how am I representing the 3? 3 lines, 3 I's, right? 3 lines. Iron 3. So here's the other version of copper, copper 2. So when you see that in a name, you are thinking Cu plus 2, and then you'll cross it over. So really, it makes it a little easier. Iron 2, Fe plus 2. Cross it over. All right? So when we have atoms that have more than one possible charge, number 1, it'll be indicated in the name, or number 2, when we figure out what type it is, we've got to put it in the name when we do the naming. It'll either be indicated or we've got to figure it out. Am I proceeding? Yes, good to go. Felicia, I don't know what you're doing back there. There's all kinds of action going on back there, but I'm not sure. It's okay. Okay, what do we got here? Hold on, don't write this. This looks like a lot of writing. If an ionic, and we don't want to, hurt the princess. If an ionic compound contains a multivalent metal, name of the metal includes the charge. I think that's the case. Examples. Go to examples. No need to write that statement down there. Provide the chemical formula. Now, this is the easy one. Determining the formula is the easy thing. You're already telling me the answer? Yep. Goodness gracious, let some people write it down. Like Shay probably wants to give the answer. You should. No. But it's fun sometimes. Okay, iron chloride. I'm going to do this with you for the first one, and then you can tell me the second one. Iron Fe. Now, if we look at iron for the charge, we notice that it has 2 and 3. We actually don't have to go looking, but there's 2 possibilities. So in the name, we will be told what the charge is, 2. So I know that that's a plus 2. We don't need to write it down. We're just going to cross it over. I'll write it down for the first example just to make the point, but this is a plus 2. Because of this 2 right there, that goes right into there. This is really more for the video for the people who are not here. So the chloride, right, is then going to be Cl, which we know from our periodic table is -1. And just as before, we will cross them over, and we will have FeCl2, iron 2 chloride. Okay? Was there a question? Lead is right here. So lead 4 sulfate, Pb. Yep, what am I doing? You want to put a 2 there? Okay, then what? Yep. Yep. Okay, so you took the 4, crossed it over, and the 2 and crossed it over. Is there a common factor in those numbers, 2 and 4? We can take out the 2. So then this is going to become a 1, which we don't write in, and this is going to become a 2. So the final is PbSO4 2. And that's what makes going backwards the other way. We're going to do some examples of that in a moment. But if you look at this formula, you see that 2 out there, it might make you think that it's a lead 2. But it's actually a lead 4 because there was some canceling out. So we're going to have to come up with a trick to figure out which version of lead it is when we do the practice the other way. And there is a way to do it. It's quite easy. Okay. So let's now go back the other way. Oops. What's happening to my examples? Okay. Right there. All right. Now, I have taught how you figure out what goes in the brackets, I've taught this 3 different ways. And you can talk about doing the crossover backwards, but that doesn't always work, because if you canceled something out, then it doesn't give you the same numbers when you go backwards because you canceled something out. So the way I've determined the easiest way to do this is to simply figure out what the formula is using both possibilities and then seeing which one gives you the formula that we want. Let me show you step by step. I look at that formula and I know that I have iron. And I go and I look at iron and I see that there's 2 possibilities, 2 and 3. So I put brackets because I know I'm going to need them, but I don't know what goes in it yet. But that's okay. I know I'm going to need to put something in it by the time I'm done. What do we call this back part here? What's it going to be? What do you got? What do you think? Oxide. Very good. Oxide. So it is an iron blank oxide. So now go to your periodic table. What are the 2 choices for iron? Yep. 2 and 3. Well, if it was iron 2, and you crossed over the 2 from the iron, and what's the charge on an oxygen or an oxide? So if you had 2 and 2, what would have happened to the 2s? So what if you had 2 and 3? And which one is that? Because that's the formula it gets me. Do you see the logic there? If it was the 2 and 2 would be gone, but that's not the formula I'm looking for. If it was the 3, oh, that's the version that gets me that. It must be iron 3. Do you see the logic behind it? So what I ask you to do is recognize that it has more than one, leave a blank, and then quickly test both of them to see which one gets you the correct formula. Then you know which one it is. Let's do another one. So what is Ni? Yep, nickel. Nickel. And if you take a quick look at nickel, you'll notice there's 2 possibilities, right? And you could even keep those numbers in your mind. So what I do is I just put blank. What's the last part going to be called? What is that? Yep, the sulfide. Sulfide. So now I'm checking the 2 possibilities to see which one gives me this formula. Of the 2 possible ones, when you cross over and do your thing, which one gets you that? Isaac? 2 gets me that, right? Because the 2 and the 2 cancel. 2 gets me that. That's how I know it's nickel 2. The other choice was a 1, correct? So you would have had then an Ni2S, I believe, and that's not that case. That wasn't the case. Oh, it's a 3? So then it would have been, yeah, Ni2O would have. All right, what do we got? One more example here, and then again, there's another sheet, but we're going to be right to a bell. We're going to do a lab tomorrow, and then there'll be time at the end to work on that last sheet. If you want to work on the sheet that's on there, you can do it for homework, you can do it for practice. And then you can also do the summary now, because the summary, you needed this. Front part, what's it called? What's the front part? Chromium. Chromium. And what are the 2 possible charges? Yep. 2 and 3. What is this back part called? Yeah, very good. It's a nitrate. And so which of my 2 possible charges gets me that formula? Isaac? Yeah, it's a 2, because the 1 and the 2 cross over. That is a chromium 2. Okay, we will end there. It's perfect. Again, there's a sheet on that second entry, because I meant to do this on actually on Tuesday, but you guys have got this pretty good. So you can do that homework on that second entry. And then there's also the summary sheet that was on the first entry that you can also now do. Excellent. And I will stop recording again.